All right, let's keep rolling with video 2 here. All right. So we have, I think, a couple special scenarios maybe after this first question. This first question is a finding one. So now we have to see the graph and find the inequality from this picture. All right. So first thing that I would do is I would go ahead and find the equation of the line, y equals mx plus b. So the first thing I'll do is I'll start with the b. The b again is the y-intercept. So where does this line cross the y-axis? Right there. That is the point 0, -3. -3 is the b value, right? So I know my b is -3. Okay. Now the slope. So got to find another nice point. Well, this point's nice right there. Count the rise and run. Up 1, right 1. Our slope, which is rise over run, is up 1, right 1, which is a +1 over a +1, which is just 1. So our b value is -3 and our slope is 1. So watch. Y equals 1x minus 3. You don't need the 1 in front of the x, so this is really y equals x minus 3. So that's the first part. That's the inequality. The second part is now the shading and the, just basically the inequality symbol, right? So if you look here, right, this is a solid line, which means you're going to have an equal to. You are shaded above the line, right? Going up. Above means greater than. There's your symbol. Greater than or equal to. That is going to replace our equals right there. So this inequality is y is greater than or equal to x minus 3. There you go. All right, I think I got 2 more. All right, next one here. It says, what is the graph of the inequality in the coordinate plane? So we have x is greater than or equal to 3. Notice that this is only one variable, but we're still graphing it in the coordinate plane. We need to notice that this has no y involved. So this is a special line. It's not going to be diagonal like the one in the previous example or the other 3 examples we've done. So remember, right? First we graph the line x equals 3. What this is saying is all points look like this, 3, y, where x is 3 and y can be anything. X is 3 and y is anything. X is 3 and y is anything. X is 3. Notice all these points have an x value of 3. Therefore, it is going to be a vertical line. Vertical. Going through the x-axis. Now, the second part is, what about the type of line? Well, it is a greater than or equal to. Equal to means solid. Greater than means above. Now, in this case, let's watch. When I make this solid vertical line, I don't have above or below. I have left and I have right. Well, this greater than, think of positive, right? Above is positive. Well, in the x direction, right is positive. So you're going to shade to the right. And this is the solution space over here. Any point on that line and any point to the right of that line. All right, last one here. All right. So it looks like now we'll do y is less than 2. So again, it only has one variable, special type of line. This does not have an x. So remember, graph y equals 2, which means all points look like this, x, 2. That means you can go anywhere left or right, but you go up 2, up 2, up 2. And notice that your line is going to be horizontal, right? Special kind of line. Now we have to ask ourselves, what about the inequality symbol and how it's going to look? So this is just a less than. So we are a dashed line, or dotted line, whatever you want to call it. And less than means we're going to shade below. So here's my dashed horizontal line. And below would be this way, down, right? So all of this is the solution space. Anything with a y less than 2, any point with a y less than 2. But again, this does not include the boundary line. All right, there we go. So graphing linear inequalities in two variables. All right, best of luck on your practice.